My name is Isha Vij. My student number is 2181233307 and today's date is March 27, 2022. In this video, I'm going to be talking about the Bronsted-Lowry acid and base. Before getting into details, I'm just going to be giving a couple of definitions to make this smoother. A Bronsted-Lowry acid is defined as a substance that gives up or donates hydrogen ions during a chemical reaction. A simple definition of this is a hydrogen ion donor. A Bronsted-Lowry base, on the other hand, is defined as a substance that accepts the hydrogen ions during a chemical reaction. And simply put, a hydrogen ion acceptor. A conjugate acid is a chemical compound formed when an acid donates a proton to a base, or simply a base plus a hydrogen ion. A conjugate base is a chemical compound formed with what is left over after an acid has donated a hydrogen ion. A simple definition is basically acid minus a hydrogen ion. So one key note to just note before we move on is that a Bronsted-Lowry acid and base are always on the left side of a chemical reaction, whereas the conjugate acid and bases are on the right side of a chemical reaction. We are going to be talking about an example, and we're going to be using hydrogen fluoride and when it is put into water. So when it is put into water, it partially dissociates because it is a weak acid. This is a known fact. And so we have hydrogen fluoride plus H2O forms hydronium plus fluoride ion. This hydrogen fluoride dissociates to form a fluoride ion, and then that dissociated H that's remaining will be donated to water, so H2O. And this in turn will form H3O or hydronium. Also to note that this process is in dynamic equilibrium because it can go forward or backward, which is indicated with those forward and backward arrows. They are both happening at the same time and they are equal. We are going to be thinking about this in terms of hydrogen ions being exchanged. Whenever we're looking at the hydrofluoric acid, we are looking in the forward direction. It is becoming just fluoride ion. It loses a hydrogen ion because, it's donating it to H2O. And so, that's why it's losing the hydrogen ion. Whenever we look at water, it is gaining a hydrogen ion. So when it gains a hydrogen ion, it is basically getting another H. And so whenever we go back to a reaction, now we can identify the Bronsted-Lowry acid, the Bronsted-Lowry base, the conjugate acid, and the conjugated base in a reaction. Because now we know what is gaining and what is losing an H, or a hydrogen ion. So in this case, the hydrogen fluoride, or HF, is a Bronsted-Lowry acid because it is donating an H to water, okay? And at the end, it forms fluoride. Then our water, in this case, is a Bronsted-Lowry base as it's accepting the hydrogen from the acid or hydrogen fluoride. And so whenever it accepts that hydrogen from the acid, it becomes a Bronsted-Lowry base. So we have gone our Bronsted-Lowry acids and Bronsted-Lowry base. Now it's time for what is a conjugate acid and what is the conjugated base. Basically, in this case, we have a conjugate acid as something that is the base plus the hydrogen ion. So in this case, conjugate acid is the hydronium and the conjugate base is the fluoride. This is because it fits the definitions of conjugate acid and the bases as its base plus H and its acid minus the hydrogen ion. One final reminder is that a Bronsted-Lowry acid always forms a conjugate base and a Bronsted-Lowry base forms a conjugate acid. It is always the opposite. I hope this video has helped you learn more about Bronsted-Lowry acid and bases and conjugate acid and bases. Thank you so much for listening.